Welcome to Mastering Solutions. This problem is getting a little trickier only because of how you set it up. The math, as far as how we calculate the answer, is very similar to some of the past problems that we've done so far for this section. And so the main thing that you have to remember for this question is that with diffraction, the single slit in the circular aperture especially, if you have a slit or if you have an object like a wire for single slit, or in this case, a fog droplet, if it's small enough size, it acts in the same way as if it was an aperture. And in this case, what we're trying to solve for is D. Because what's happening is these fog droplets are passing in front of the laser, and the laser diffracts as if it was a circular aperture. So let's continue our list and write down all the other information they give us in the question. We know that lambda is 690 nanometers for our laser. We're told that the central maximum, so W is equal to 0.28 centimeters, 10⁻² meters. And the pattern on a screen is 30 centimeters. So the screen is 30 centimeters from the droplet, so L is 30, 10⁻² meters for L. So I believe that's all the information that we're given in the problem. So let's write down the equation that we'll be using for this, and that's W is equal to 2.44 times lambda times L all over D. We're trying to solve for D, of course, so we'll multiply both sides of the equation by D, and then we'll divide both sides of the equation by W. So now we have D is equal to 2.44 times lambda times L over W. So the D and the W swapped places, of course. So when we plug in our information now, we have D is equal to 2.44 times lambda, which we said was 690 nanometers, -9. L in this case is 30 times 10⁻² meters. And all of that gets divided by W, or the width of the central maximum, and we said that was 0.28 times 10⁻² meters for centimeters. So when we go to our calculator, we have 2.44 times lambda e -9. Oops, and then we multiply that by L, so 30 times 10⁻². Now that all gets divided by D, which is 0.28 times 10⁻². So our answer is going to be 1, 2, 3, 4, 5, 6, and we'll round that to 180. So D for this question is 180 times 10⁻⁶ meters, or 180 microns. And that is the width or the diameter of the fog droplets in this question.